We shall find the sufficient statistics for estimating theta given the Poisson distribution. Solution. For more on this topic, you need to subscribe to this channel. The factorization theorem is used to find sufficient statistics. And the factorization theorem states that a statistics is said to be sufficient if and only if it satisfies this condition. That means the given PDF can be factored out into two components, while one of the components will depend on the parameter given and the other component will depend on x. Yes, the factorization theorem states that a statistics is said to be sufficient if it can be factored out into two components. This is one of the components and this is the other component. So we are given the Poisson distribution. The next thing to do, for we to factor this out, or to see if it can be factored out, we'll take the likelihood function. That means f of x theta is equal to the product sum as I ranging from 1 to n to the function given or to the PDF given, which is equal to the product sum of the Poisson distribution, which is theta x exponential negative theta all over x factorial. So this is the Poisson distribution. The next thing to do is that we'll now take the product sum, because this sign means the product. So we'll take the product sum of this function, and the product sum will give us, the first one will be theta x1 exponential negative theta all over x1 factorial multiplied by theta x2 exponential negative theta all over x2 factorial, and it continues like that to give us theta xi exponential negative theta all over xi factorial. So this is what we get. Now, we can easily write what we get, This is what we get when we take the product sum of the Poisson distribution. So we can finally write what we get after taking the product sum to be theta, because if you sum this n times, we get theta raised to the power of summation of xi as I ranging from 1 to n multiplied by exponential negative. If you sum a constant, you get n times that constant. So we'll have n theta all over summation of xi factorial as I ranging from 1 to n. So this is what we'll get when we take the product sum of all of this. This is what we get. So our PDF or our function is now this. So how can we now factor this out? How can we factor it out? Of course, if we watch out, theta depends on this. Theta depends on this as well. The x here depends on theta. The x here depends on theta. So we'll now come back to our factorization theory to see how we can now compute the sufficient statistics for the Poisson distribution. So we move over to this side of the board. For more on this topic, you need to subscribe to this channel. Alright, so we can now write our function to be, you say by comparing we'll have f of by comparing with f of x theta is equal to, we wrote it earlier, pi theta mu x1 x2 to xn theta, as this part depends on theta, while this part does not depend on theta. So we are comparing it with this. If we have our function or our PDF to be theta summation of xi as I running from 1 to n exponential negative n theta all over summation of xi factorial as I running from 1 to n. Of course, if you see, we cannot separate any of these because they are together with the Poisson distribution. So we say multiply by 1. So this becomes one part of the component and this becomes another part of the component. So this part of the component is what we have as pi theta into into mu x1 x2 to xn theta multiplied by this other component becomes h x1 x2 to xn. Why this 1? Because this does not depend on theta. This does not depend on theta, so it can be 1. Why this depend on theta? We can also rewrite this as pi theta into mu x summation of xi's as I running from 1 to n theta and multiply by, you say or multiply by h. This does not change because it does not depend on theta. So this is 1. So we can simply say our statistics, our mean is a sufficient statistics for estimating theta. For theta. So this is how we can compute the Poisson distribution in finding the sufficiency as relating to theta. For more on this topic, you need to subscribe to this channel.